welcome back. So today we are going to take a look to see how we can use the quantum numbers that we looked at yesterday to describe the probable location of our electron. So as a quick review, we are going to go over the different quantum numbers that we discussed yesterday. Remember, the purpose of these quantum numbers is to describe the probable address of our electron. So our first quantum number was n. That was our principal energy level. And that told us which energy level, or if we think about an apartment complex, which floor our electron is living on. Remember, our possible values for energy level start at 1, and then they can go all the way up to infinity, theoretically, depending on the size of our atom. Remember, as we get further and further away from our nucleus, the higher energy level we are going to be looking at. The second one is going to be our sub-level quantum number. This is going to tell us what shape are our electrons making as they move. Okay? And if we think back to our apartment complex or dorm analogy, we can think, what type of room are our electrons living in? So remember, our possible shapes we could be making are the sphere for S, the peanut for P, the D for daisy, and the F for flower. And remember, as we move down, we increase in energy and size. So S is going to be our lowest energy sublevel and our smallest sublevel, whereas F is going, or our flower is going to have the most energy and it's going to be our biggest. Okay? So then once we know what shape our electrons are making, we have to look and see which orbital exactly is our electron in. Or if we think again back to that apartment or dorm analogy, we can think, what bed is our electron living in? The other thing we kind of look at this is how are we looking at our electron? So here we need to think about how many different ways are there to look at the different shapes we talked about in our sublevels. Remember our S for sphere, there's only one way to look at a sphere. So there's only one possible bed our electron could live in the S sublevel. Think our P for peanut, there's going to be 3 different ways we have of looking at that shape. So there's 3 different orbitals or 3 different beds our electrons could live in there. Our D for daisy, there are 5 ways of looking at it. So there are 5 possible beds or 5 possible orbitals that our electrons could live on. And then F, that's our highest energy, and there's going to be 7 ways of looking at that flower. So we're going to have 7 different orbitals or 7 different beds that our electrons could live in the F sublevel. Okay? And again, just like we talked about the sublevel, we can see as we move from S to P to D to F, we're going to get larger and larger because there's more ways to look at it. There's going to be more orbitals or more beds. And then our last quantum number is going to be S. That's talking about what direction is our electron spinning. Is it spinning clockwise or counterclockwise? Okay. So we are going to use these 4 main ideas, these 4 quantum numbers, to come up with the address or location of our electron. Okay? And our big question for today is, how do we know the order in which our orbitals or beds are filled? Or in other words, where are our electrons going to go first? Okay. So there's going to be 3 key ideas that we're going to look at to answer this question. Okay, all are going to be named after the scientists who came up with the idea. And always got to tip our hat with the scientists that developed an idea. Okay, so the first person we're going to look at is Aufbau. Okay, so the Aufbau principle. He said that electrons are going to enter our lowest energy orbitals first. So if you think about walking into an apartment complex, we are going to fill the first level first, then the second, then the third, and so on. So we're going to fill those lowest energy floors or lowest energy orbitals first. Okay. So remember, our first energy level, that's obviously the lowest, but then when we're looking at sublevels, our sphere shape is also the lowest energy. That means our 1s orbital is going to be filled first because that's our lowest energy room. Oops. Okay. The second key idea is that the Pauli exclusion principle. And Pauli said that no 2 electrons can have the exact same address. So what that means is each individual electron in your atom is going to have its own set of quantum numbers. This means we can only have, at most, 2 electrons per orbital, or 2 electrons per bed. And that makes sense, right? Because if you were sleeping, you wouldn't want more than one other person in there. Okay? And if we have 2 electrons in the same bed, they need to have different spins. So one will have to be spinning clockwise, and one will have to be spinning counterclockwise. Okay? Everything about our bed analogy, we're basically going to be sleeping head to feet. Okay? And our last key idea here is going to be Hund's rule. So what this means is that when electrons occupy orbitals of equal energy, so let's say we look at all of our 2p electrons. Our electrons are not going to pair up until they have to. And until there is no more empty bed. So if you think about on a bus, if you walk into a bus, you would probably choose to sit by yourself before sitting next to a stranger. It's the same thing with our electrons. When we're looking at equal energy, okay, so we're just looking at 2p orbitals, let's say, they're each going to occupy their own orbital before they pair up with somebody. Roadmap that tells us how our electrons are going to be placed in our atom based on the different energy levels. So we're going to create a roadmap or a little yellow brick road that will tell us the order in which we fill our electron sublevel. So we know we have to start with the lowest energy. So we're going to start with our 1s. Remember, our sphere is our lowest energy shape, and we're going to start at that first energy level. Because Aufbau's principle tells us we're going to fill those lowest energy orbitals first. Notice how there's not a 1p, a 1d, or a 1f because we don't have enough energy to make those different shapes yet. So we'll start with our 1s, and then we're going to kind of snake back around and fill our 2s. Okay, because our 2s is our next lowest energy level. Okay, Then we'll come back to where we left off. The next thing we're going to fill is our 2p. Okay, we're in the second energy level, but now we're making a peanut shape. And now we're going to fill the 3s. Okay, let me draw that a little bit better. Okay, so we're basically arrows are going to tell us the order in which we're going to place our electrons within our atom. So after 2 peanut, our electrons will move to the 3s. So they'll be in the third energy level, making a sphere. Then we'll come back around and fill the 3p. So now we're still in the third energy level, making a peanut shape. And then it just so happens that the 4s is the next energy level. So after our electrons are placed into our 3p sublevel, so the third energy level, making a peanut shape, the next place they'll go is that 4s. So our fourth energy level, making a sphere. It just so happens that our 4s requires less energy than our daisy. Okay, so after the 4s, okay, we'll kind of snake back around again. Now we'll fill up our daisy. So now our electrons will go to the third energy level, making a daisy shape. After we fill that level, move to the fourth energy level, making a peanut shape. And then next we'll fill our sphere in that fifth energy level. So if we follow these arrows, kind of like a little yellow brick road, it will tell us the order in which our electrons fill these sublevels. So then after placing electrons in the 5s, we're going to come around, put them in the 4d. So we'll put them in the fourth energy level, making a daisy shape. After that sublevel is filled up, our next electrons will go to the energy level, making a shape. And then if we have any extra electrons, they'll go to the sixth energy level, making a sphere shape. Okay. After that sixth energy level, now we'll have enough energy to make that flower shape. So we'll snake back around. After placing electrons into the 6s sublevel, now our next lowest energy level is the 4f. So we'll be in the fourth energy level, making the flower shape. After the 4f, we'll go to the 5d, followed by the 6p and the 7f. Okay. So notice how we don't have enough energy to make the flower shape until we get to that fourth energy level. And our 4f is actually going to be higher in energy than our 6s. That's why we'll fill our 6s sublevel first and then do our 4f. Okay. So how we're going to do this is we're going to follow our arrows to fill in our orbitals in the order of lowest to highest energy. Okay, so let's look at what this actually looks like in practice. So let's look at helium. If you look at helium on the periodic table, it has an atomic number of 2, so it's only going to have 2 protons and 2 electrons. Okay. Where the 2 electrons are going to go, we're going to follow our map. And we are going to see that the 1s is the first level that we fill. So we're going to start off with our 1s sublevel. With the sphere, there's only one way to look at a sphere. So there's only one possible orbital or one possible bed in the 1s sublevel. Okay, so we'll put 1 electron in there. If we remember, we can have a maximum of 2 electrons in a sublevel. Okay, and we're using arrows to represent electrons. So this means I can put another electron into that 1s sublevel, but it needs to be spinning the opposite direction. And I'm going to show that by including a downward facing arrow. Okay. So remember, I can put at most 2 electrons per orbital. And my 1s only has 1 orbital because there's only one way to look at a sphere. And if my electrons are in the same orbital, they need to be spinning opposite direction. So I'll have an upwards facing arrow or a clockwise electron and a downward facing arrow or a counterclockwise. Okay. We can also show this by writing 1s2, where that 1 tells us our energy level. The S tells us what shape we're making. And the 2 will tell us how many electrons we have in that sublevel. Let's look at another example. Let's say we want to label or classify where carbon's electrons are. So we look at carbon on the periodic table. It has an atomic number of 6. So that means we have 6 protons and 6 electrons. We want to say where those 6 electrons are found in our atom. So we're going to follow our arrows like the yellow brick road to tell us exactly where are we going to put those electrons. Remember, we start in the lowest energy orbital first. So that's going to be your 1s. We can only fit 2 electrons per orbital. And since our 1s only has 1 orbital, that's only going to take care of 2 of our electrons. That means we have 4 more electrons we need to place. So after that 1s, we're going to come around, and now we'll do our 2s. 2s, again, there's only one way to look at a sphere, so there's only going to be 1 orbital or 1 bed. So we'll put our 2 electrons in that 2s, because now I have placed 4 electrons, so I only need 2 more electrons to locate. I'll come around. I'll see after my 2s, I'm going to fill my 2p. So after 2s, the 2p is the next lowest energy sublevel. If you guys remember, there's 3 ways to look at a p-net. So I'm going to have 3 different orbitals in my 2p sublevel. Okay, so I have 6 total electrons that I need to place for carbon. I've already placed 4, 2 in my 1s and 2 in my 2s. So that means I have 2 electrons left that I need to place. Remember, our electrons are not going to pair up until they have to. So because of that, I'm able to put my 2 electrons in different beds or different orbitals within that 2p sublevel. Okay, because they're not going to want to pair up until there's no empty spaces left. Okay, so I can see here that I have 2 electrons in my 1s, 2 electrons in my 2s, and 2 electrons in my 2p. If I want to double check that I did this right, if I add each one of these exponents, that tells me how many electrons I have in each level. So here I have categorized a total of 6 electrons, which is how many electrons my carbon atom has. Okay. All right, let's look at another one. Let's do sodium this time. So sodium, when I look at the periodic table, it has an atomic number of 11, which tells us it has 11 protons and 11 electrons. We want to find exactly where are those 11 electrons going to go. Okay, so first we'll fill up our 1s. Remember, start with the lowest energy first. There's only one way to look at a sphere, so we're only going to have 1 orbital or 1 bed in that 1s sublevel. So remember, we can fit 2 electrons per orbital, so we'll have 2 electrons within that 1s sublevel. We follow our yellow brick road. After the 1s is going to come our 2s. Again, there's only one way to look at a sphere, so we're only going to have 1 orbital there. Place 2 more electrons, and remember, they're facing opposite directions. So far, we've placed a total of 4 electrons, which means that we have 7 left. So after our 2s, we'll come around and we'll do our 2p. There's 3 ways to look at our p-net. So our 2p sublevel is going to have 3 beds or 3 orbitals. So I'll give each electron its own bed first. Okay. So when I do that, I've only placed 7 electrons, 7 total. That means I have 4 more. So I'm going to have to double up the electrons within that 2p sublevel. Okay. So now my 2p is completely filled. So again, we'll follow the yellow brick road and we'll see after the 2p, we're going to go to the 3s. So after 2p, 3s is the lowest energy orbital. So far, I've placed a total of, let's see, 10 electrons. So 2 in my 1s, 2 in my 2s, 6 in my 2p. So that means I have 1 electron left that's going to go in my 3s. Okay. So for all 11 electrons, we'll have 2 in my first energy level making a sphere shape, 2 in the second energy level making a sphere shape, 6 in the second energy level making a peanut shape, and then 1 in my third energy level making a sphere shape. So again, the purpose of these electron configurations is to show where are each of our electrons. What energy level are they in? What shape are they making? And how many electrons do we have in that sublevel? So this one is going to get a little bit more complicated because zirconium, if you look at the periodic table, is going to have an atomic number of 40. So that tells us zirconium is going to have 40 protons and 40 electrons. We're going to have Okay, so we're going to have to find exactly where all 40 electrons are located and what shape are they making as they move. So remember, we always fill that lowest energy sublevel first. We're going to start off with our 1. Only one way to look at a sphere. We'll place 2 electrons in that 1s. After the 1s, we're going to come around and do our 2s. Again, only one way to look at a sphere. So we're only going to have one orbital for a 2s or one bed. Place 2 electrons there. So right now we've placed 4 electrons. So 1, 2, 3, 4. That means we have 36 to go. So after the 2s, we're going to have the peanut shape in our second energy level, or 2p. So we'll give each one their own bed first, but then we're going to have to double up because we have quite a few electrons to go. So we have 3 ways to look at a peanut. So we have 3 different beds or 3 different orbitals within that sublevel. Follow our arrows. After the 2p, we're going to hit the 3s. Again, for a sphere, there's always only one way to look at it. So put 2 electrons. So here let's kind of double check to see how many we've placed. We've done 2 in the 1s, 2 in the 2s, 6 in the 2p, and 2 in the 3s. So currently we've done a total of 12 electrons. That means we have 28 to go. So we still have quite a ways. So if we look at our arrows, after the 3s, we come back around, and now we're going to hit the 3p. Okay? Remember, anytime we have a peanut, there's 3 ways to look at it. Okay, so we're going to have 3 different orbitals or 3 different beds for that 3p. We'll give each electron their own bed first. Okay, but we still have 25 electrons we need to place, so we're going to have to start doubling them. Okay. So right now we're sitting at 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so right now we've placed 18 electrons. 18. Okay. That means we have 22 we need to go. So we're still not quite done. So we come back to our list, and we can see after the 3p, our 4s is going to be the next lowest energy level. Okay, so next we'll put our electrons in the 4th energy level, making a sphere shape. Okay, it just so happens that it takes less energy to be in the 4th energy level, making the sphere shape, than right away jumping to the 3d. So make sure you guys pay attention to that order. All right, but so here we're halfway there. At this point, we've now plotted 20 electrons. So we have 20 electrons to go. So we come back up. We need to find where to go after the 4s. We're going to come back down, and we'll see that now we're going to the 3d. Okay, or we're making the daisy shape in the 3rd energy level. Remember, there's 5 different ways to look at the daisy. So we're going to have 5 different orbitals or 5 different beds that our electrons be in. Give each electron its own bed first. Okay. So now we have 15 more electrons to go. So I have to double up. Okay. All right, so once we do that, once we put our 10 electrons in the 3D, so 2 per bed, Now we only have 10 left that we need to plot. Okay, so we come back up to our list and we'll see after the 3D comes the 4P. Okay, so go 4S, 3D, and then 4P again. Remember, anytime you have a peanut shape, there's 3 different ways to look at it. We have 3 beds. Each person, their own bed first. Okay. But we still have 7 we need to go, so we'll have to double up. Okay. So once we add up all those electrons, so 2 in the 1s, 2 in the 2s, 6 in the 2p, 2 in the 3s, 6 in the 3p, 2 in the 4s, 10 in the 3d, and 6 in the 4p, we're going to see that we have 4 more electrons. So we'll come back up here and we'll see after the 4p, now we're going to go to 5. Okay, so our next lowest energy level is having electrons in the 5th energy level, making a sphere shape. So we said we needed to place 4 more. So I'll put 2 electrons in that 5s, which means I have 2 electrons left, which are going to have to go into my 4D. So I'm coming back down here. Remember, in a D, there's 5 different ways to look at it. 1, 2, 3, 4, 5. We said we only needed to place 2 more, so these 2 electrons will each get their own bed. Okay. So now, if we add up all of my arrows, which represent our electrons, we should find that we have a total of 40 electrons placed. Okay? And if we want to describe where each one is, we could say we have 2 in the 1s, 2 in the 2s, 6 in the 2p, 2 in the 3s, 6 in the 3p, 2 in the 4th energy level making a sphere, 10 in the 3rd energy level making a daisy, 6 in the 4th energy level making a peanut, 2 in the 5th energy level making a sphere, and 2 in that 4th energy level making a daisy. So again, the main thing is follow the yellow brick road, follow the arrows until all of your electrons are placed. Okay? And we can either do this in shorthand notation, so by showing just kind of quick what energy level, what shape, and how many electrons, or we could show how each of those orbitals are filled by drawing the arrows. Okay. And again, once we add up all these exponents, they should add up to 40 because zirconium has 40 electrons. To show where each of our electrons of an atom are located, we're going to look at just one more thing. We're going to look at a topic called valence electrons. So when we refer to valence electrons, we're only looking at electrons at most energy level. So remember, the outermost energy level is the one farthest from the nucleus. Okay. So if we look at the previous example, if we look at helium, we only have one energy level. We just have our 1s. Okay? So since we only have one energy level, one sublevel, that means our valence electrons have to be located in that sublevel. So helium then would have 2 valence electrons. Because in the sublevel farthest from the nucleus, there's 2 valence electrons. And if we look at carbon, when we're looking at valence electrons, we want to look at the highest or the outermost energy level. So if we look at our coefficients, the highest number we'll see is our 2s and our 2p. Okay, so those are outermost energy levels because those are the levels with the most energy. So if we have 2 electrons in the 2s, 2 electrons in the 2p, that means in total in that second energy level, or that one farthest from the nucleus for carbon, we would have a total of 4 valence electrons. Okay. Same idea if we look at sodium. Here, our furthest energy level is at 3rd energy level. We have our 3s. We only have 1 electron in that 3s sublevel, or that energy level furthest from the nucleus. So that means sodium would only have one valence electron. Okay. Zirconium, this one gets a little trickier. If we look at our electron configuration, the highest coefficient we're going to see is this 5. Okay, so that 5s is that one furthest from the nucleus. Since that 5s is the one that's furthest from the nucleus, and we only have 2 electrons in that 5s, that means zirconium would have 2 valence electrons. So if you're looking at valence electrons, do your electron configuration. Find where all your electrons are located. And then look to see how many electrons you have in that outermost energy level, or in that energy level furthest from the nucleus. Okay? So please let me know if you have any questions on these electron configurations or finding where exactly in the atom all of our electrons are located. Otherwise, work on your homework, and I hope you have a great day.